Welcome to Science Exposed. I'm Patty.
And I'm Tracy.
And we're from Praxis. And today we want to talk about science and demystifying what people think science is about and how it's difficult and you can't do it. Because all the experiments we're doing here, you can do at home with an adult supervising you. And it's tons of fun. And we just want to show you that science is in everyday life. So, how about let's get started?
Sure. The first thing we're going to do is an experiment that will show us surface tension. And I have with me some dry ice.
Oh, but just a minute, Tracy. When we're doing any science experiment, what should we do? First, we should put on our safety goggles. We're already wearing our coats so we don't get them dirty, but safety first. Dry ice could be a little dangerous, so let's put our safety goggles on.
Okay. And since dry ice is so cold at minus 78.5 degrees Celsius, I can't touch it with my bare skin.
Good. Put some gloves on
So
for
that
safety.
is really good. I'm going to give you a pair too.
Oh, thank you. Yes.
So now I have my dry ice.
You can see it's been sitting in this bowl for a while. What is that happening on the outside of the bowl here? It's starting to freeze the bowl because it is so cold.
So cold.
Okay.
So dry ice is frozen carbon dioxide, and frozen carbon dioxide is in a solid state, and it does not have a liquid state in our atmosphere. It goes directly to gas. That's called sublimation.
And that's what you see happening here in these, is that it's starting to gas off, and the white, there's nothing special in there. It's just some water, and it's just the white is starting to come off as a gas.
So what I'm going to do is I'm going to add it to some bowls here, and the only thing in these is a little bit of warm water. So when I drop the ice pellets in, it's going to start sublimating, and you might see it start to condense really quickly.
What does sublimating mean?
That's when it goes from the solid state directly to the gas.
Exactly.
I already told you that.
Well, I was just making sure. I forgot.
Okay. Okay, so this one's your bowl.
Oh, okay. Wow.
This one's my bowl.
We share?
Yes.
Thank you. Okay. So you can see the frozen carbon dioxide are just little pellets. And as we start adding them, you're going to see it gassing off.
You need some more.
More? Okay. Well, here, I'll help myself.
It's like a Halloween candy bowl.
Yeah, exactly.
Okay, so now what we're going to do is we're going to take our solution here, and all that's in this is a little bit of Dawn soap. It's a sudsy mixture, and there is a piece of cloth in here for you.
Excellent, thank you.
And for me. And we're going to try to make a crystal ball.
So we just separate this out?
Yeah, just like this. See, you can see it's dripping wet with the sud mixture. And we're going to drag it across. Oh, you got yours already?
So it looks like a crystal ball. Can you tell me my fortune?
Woo! So now what you're seeing here is you're seeing the film of the... Oh! I've never seen that happen before. You're seeing the film from the soap. It's creating a surface tension of sorts, which just means that it's sticking together as a type of cohesion. Now you can watch here, if I take my finger and I can pop it.
No. Okay, what if I take my finger and try to pop it?
Okay,
Do you have a magic finger? No, well, let's just see. Well, how come mine doesn't pop the bubble until it hit way up my finger?
Well, mine pops it right away.
Why didn't mine?
What did you do?
Oh, I tricked you. My finger was still wet with the soapy solution from a piece of cloth. So as long as your finger is wet and you try to stick it into the bubble, it won't pop it. It's when it got way up here where it was nice and dry, it popped the balloon. Let's try that again.
Okay. Do you want more? So this part here that we're showing is the cohesion. Oh, maybe I should do that for you. Oh. So, okay, so I want to try this. I'm going to put the mixture on my fingers. Oh, you're right. But if this hand doesn't have...
If it's dry, it pops it.
Okay.
So mine's still wet.
That's really cool.
Yeah. What else do you think we could do with this?
You know what we should try to do is here, let's take this car.
Okay.
Do you want to put some dry ice in this?
Oh, let's try that. Here, let's just move this out of the way here. This is our big bubble generator here. You can easily make this at home just with a jar and some tubing. There's just some water in here.
I'm going to drop some ice in. Oh, there's my ice. Okay, just a handful, right?
I think that'd be perfect.
A little bit more. More is better.
Now we don't want to place this on tight because you are creating so much gas in there that we don't want it to explode. So we're just going to put it on here loosely so we force it out the tube here, because the tube we're going to dip in the bubble mixture.
Okay.
And we're going to make bubbles.
Oh, yes, you are. Here, you know what? Let's put some of that on the table. Is it working? Oh, it's coming too fast now.
I think we have too much ice.
Whoops. More isn't better.
Oh, there we go. We got some bubbles. Oh, excellent. There, we're producing them now slowly.
Oh, you got a good one. How big can you make it grow?
Oh, we can make, oh. Let's see how big we can go.
So if I push down on the lid, the air comes out faster and your bubble grows more. Okay.
There we go. We're sucking that bubble in. They attract to each other.
Ah, yes. Like things attract. That's the whole idea of cohesion.
So let's see. Is this car going to be able to go in there? Let's see what happens. No. So how can we make the car not pop the bubble?
Well, it's the same thing with your finger, right?
Really? Do you think that'll work?
Wow.
Let's try it. So let's grow another bubble here.
Get the solution on our car. Okay, and now we're gonna drive it in.
Oh, let's get a nice big bubble.
Okay. Okay, say when.
Okay, give it a shot.
There it goes. And get in there. There we go. Okay. So now the car is parked in its garage.
There we go.
Ooh, can we try to catch one?
Would you like to catch a bubble?
Yeah.
Sure. Well, you have to wet your hand.
Right. Or I saw this on a TV
this
show.
works very well too. Can you catch that with your magic glove?
So close. Oh, there we go. Okay.
How many bubbles can you stack?
Oh, like a snowman. They just keep swallowing each other up.
Why is that?
Is that the cohesion again?
Yeah.
Super cool.
Excellent.
All right.
So what happens to the water when you add the carbon dioxide to the water? Because water is really basic, has a pH of about 7 because it's purified water.
Like close to neutral?
Neutral. So when we add the carbon dioxide, what happens to the water? Is there any sort of chemical reaction that's going on as well?
Well, when you think about acid rain, it's caused by carbon dioxide emissions in the air. So I'm going to say carbon dioxide is acidic.
Okay, well, let's test your theory.
Okay.
Let's demystify
My
it.
hypothesis?
Your hypothesis, excellent. So I just have a universal indicator here. This is just a graduated cylinder full of, basic water, just plain water. And you're gonna see it's green. It's green, it turns it green.
So this is just the universal indicator.
It's an indicator to tell you if something's acidic or basic because it's gonna change colors based on the pH of the substance you have here, and
So
this is water.
So at neutral, it's going to be...
It's going to be green
Okay.
because this is just pure water. It's green. So let's add some carbon dioxide, or some dry ice, which is frozen carbon dioxide.
Yeah. Okay, here I go. Safety.
Safety, thank you.
I'll just drop a few pellets in.
Couple in.
Okay. Hypothesis, it's going to change color,
Because you said it's acidic.
right? So
Just a second. So if something is acidic, what color is it going to change?
I don't know.
It's going to go more yellow.
Oh, okay.
If it's basic, it's going to go more reddish, purpley color.
Okay, so come on, yellow.
So, clearly acidic.
All right, so our hypothesis is right.
Yes. So the more you add, the more acidic essentially the water is getting. So that's why it's so much darker. So, as the pH goes down, the color changes, right? So you might have a pH here of probably 3.
Okay.
I say it's quite acidic. It looks quite acidic. It's orange almost, not even yellow anymore.
So as the carbon dioxide sublimates away, will that color change? Will it change back down to neutral? Like, can we make it change to neutral?
We can get it back to, well, we can start changing the pH by adding something to it. And we're gonna add something, I think, let's try, because we have to move back up the pH scale, we should add something basic. So something simple you have at home that is basic is just baking soda. So let's make a solution of baking soda. So in the beaker here, we just have water. And this is just your everyday baking soda you can buy at the grocery store. So we'll add.
Should I stir it?
We can just stir it like this.
So you're saying this is basic?
This is a basic solution now.
Okay.
And it's quite saturated because we still have some of the powder in the bottom here, so it's quite a heavy solution.
Okay.
Lots of it in there.
So we should get a good reaction.
We should. So,
okay.
do you want to just add a little bit at a time?
Okay, yeah.
A pipette and see what happens?
Okay.
So you can see it's so concentrated at the top. When I'm forcing that basic solution in, you can see it's turning green.
But then it's mixing, and then it's
mixing, and with the rest of it, and it's going back to more acidic. So pour some more in.
Okay.
What about if we do a really strong base? Now, a really strong base, now you need an adult to help you with this at home, would be something like a drain cleaner that you could put in. So why don't you try putting a little bit of drain cleaner in there and see what color we get.
It's got a child safety cap.
Well, that's probably good.
You gave this to me on purpose. Success.
Very
okay,
good.
so I just drop this in.
Drop some in and see what color should it change. Now, we want to go back to the bluey green, but maybe it's going to, because
purple.
It's so basic. This is a very strong base. It's going to go right up that scale and go from red probably right to purple. But that's my hypothesis. Let's see what happens.
Okay. Oh.
So you got it back?
I did, yeah.
I
Can I add some more?
Blue. Yeah, let's see what happens. Purple. So you have a very basic solution there now. So
okay.
Excellent.
Well, this is very basic. It's like a
very, it's very caustic. It can burn your skin, and that's very common with household basic things.
Okay.
Drain cleaner. So when it's high up that pH scale, be very careful with it. You should wear gloves and have safety goggles on. So that's excellent.
That was really neat.
So do we have anything else we want to do with dry ice?
Oh, I got one more fun thing that I want to try.
Okay.
Okay. So what I need the silver bowls back, actually.
Excellent.
And I'm gonna add a little bit more hot water to them, just so that the temperature differential between the dry ice and my water will give us a better reaction. I'm gonna make a bit of a mess.
That's fine.
Okay, I'm gonna make a lot of a mess.
That's what science is all about.
Getting messy.
Expect it to get dirty, get messy. Don't get mad.
Okay, here we go. So here's what I'm gonna do. This is, again, along the same lines of cohesion.
Okay.
Okay. So here's my handful. Go ahead, put some in yours.
Oh,
I'm wearing both gloves. Okay, I'll do it.
Oh, I have a glove here. I have a spare.
Got tongs too. Okay. So I'm just gonna add your regular Dawn
Dish soap.
dish soap. Any dish soap would totally work here. Okay. You ready?
Let's go.
This is my favorite part. So awesome.
You can see, because the dry ice is melting in there, it's creating that gas, and the gas is blowing the bubbles for you.
It's sublimating.
Pardon me,
melting.
sublimating.
Okay, now let's see. This is the part that I love. Okay, everything is tightly together, but when I break the surface tension, do you want to try it? This is actually safe to touch as long as you don't stick your hands inside the where the ice is.
The bubbles are safe. The gas isn't going to hurt you. There's carbon dioxide. We breathe out carbon dioxide.
Yeah.
So we can just blow it on each other and make lots of messes
Make a mess.
like this. We love to get dirty here.
That's why we're wearing a lab coat.
I know.
All right.
Oh, well, we can make all kinds of messes here. So,
super cool.
Anything else to do with dry ice today?
I think that was all I had for today.
Okay, well, thank you very much for watching us today. We hope you come back. For more information, visit our website at www.prohision.ca. praxismh.ca.
We'll see you next time.